Alright, I think this is pretty funny. Let's look at Italian brain rot. You've probably seen a lot of AI brain rot speedruns. You've seen that guy say, oh, tralaleo tralala is like 1.3 seconds, and that's pretty fast. But as an AI enthusiast, I'm pretty sure that we can do better. So today let's talk about how to beat how to beat Italian brain rot speedruns using AI. Of course, it's not fair because we are using AI and AI is a lot faster. And the AI doesn't even have to say the Italian name. Like, what's the point if it doesn't say the Italian accent, tralaleo, tralala, bombardino, crocodillo? So, let's go into a very deep, in-depth theory of how we can do this. First of all, we need good data. And this is the main part of the problem because there's a concept called garbage in, garbage out called GIGO. And if you give it bad data, you get bad results, and that makes sense. You're only as good as what you have, you're only what you eat. And so the first question is, what are we going to give the AI? On first thought, you may say, oh, just give it the entire image and see what it can do with it. Oh my gosh. Give it the entire image to work with and then see what it does. But unfortunately, the speedrun doesn't work like that. You get like odd corners, you get like these small corners, or maybe sometimes you get just the center, or sometimes you get maybe just the background even. And so the AI not only has to learn what the crocodillo, bombardino, and the tralaleo, tralala are, it has to learn the backgrounds as well. And thus, the first thing we can do is just random cropping. It's a form of data augmentation where we just crop the image randomly. So we need to crop it at different scales and different positions. So sometimes it could give us a crop like this, quite centered and quite large. Sometimes it will give us a completely random and small crop like here. It will be not very useful, but it will still be able to give us some information about the image. And that's kind of the result we want. However, it comes to another question, which is when you have very similar images. Let's say we have bombardino crocodillo and we have the is it like bombardini guslini something, I forgot. But look, both are similar, both have propellers, both have clouds sort of, and the only thing differentiating them is the animal, which is the goose versus the crocodile, and a bit of the background. So how do we make sure our detection is very robust, that it is able to detect not just the features but also the animal? So we have to make sure that there's enough representation of the animal inside the image and inside the training data. One way we could try doing this is having some sort of bounding box around the core parts of the image that we want to train with. So let's say for bombardino crocodillo, we want to make sure that the crocodile head's inside. We could have a pre-trained bounding, we could have a labeled bounding box here like this. So each of the training samples must include at least some part of this box. Then same thing for the goose, we want to make sure each of the training samples has at least some part of this box. This means that each sample will have some part of the goose or the crocodile inside, and then we can differentiate between the two very similar images. The last issue we might face is when we have different instances of the same brain rot. So this is the name I will never be able to pronounce, but there's two very common forms of this. And I think another very common one with a lot of different forms is the ballerina cappuccino. The ballerina one. That one has a lot of different forms. And so when we have different of these images, if the AI learns to only detect this, it will never work on this one if it learns and overfits on this image, and it will only learn to detect something that looks like this. And so we have to make sure our AI is generalized to not just the specific pixels, that's called overfitting, but the real features inside the image. For example, that would be the orange color, the leaf, the gym equipment, etc. So these are a few brief concerns on how we would implement such an AI model, and maybe in the coming days I'll figure out how to actually do it.